Okay, so this is the answer to slide 9. Again, we're asked to find all solutions. This will take a little longer, so I've set things up to speed along the process. If x equals 3 is a solution, I know x minus 3 is a factor. So I'm going to divide this by x minus 3 so I can write this in factored form. So after setting up my box, I've got again, two middle terms, so therefore I need those two diagonal columns, and the first term and the last term means 3 total columns. This is x cubed. This diagonal would be combine the middle terms to get negative 5x squared, plus 11x, minus 15, and one of the factors is x minus 3. This will be the other factor here. So x times what gives me x cubed is x squared. X squared times negative 3 is negative 3x. Negative 3x plus, oops, I missed the squared. Negative 3x squared plus what equals negative 5x squared? Negative 3 and negative 2 is negative 5. So this needs to be negative 2x squared, and a negative 3x squared is a negative 5. X times what equals negative 2x squared would be negative 2x. Now that we have that, negative 2x times what? I'm sorry, times negative 3 would give me this value here. Negative 2 times negative 3 is a positive 6x. Again, this diagonal needs to combine to equal plus 11. So 6x plus 5x would equal plus 11. X times what equals 5x is plus 5. And double check our work. 5 times negative 3 does equal negative 15. So that means that this factors to x minus 3 times x squared minus 2x plus 5 should equal 0. So now that we've done the factorization of this, we could set both of these equal to 0 and solve. However, when I set this one equal to 0, this does not factor nicely like the last one did. This one we know already gave us the answer x equals 3. But this is going to give me two solutions. We can't get it from factoring, so we'll need to use the quadratic formula. In this case, my a value is 1. My b value is negative 2. And my c value is 5. So I'll plug that into the quadratic formula. X equals the opposite of b, the opposite of negative 2 is 2, plus or minus the square root, b squared, negative 2 squared is positive 4, minus 4 times my a value times my c value. And all of that is divided by 2a. So again, my a value is 1. So that's what we have here. So simplifying this gives me x equals 2 plus or minus the square root of 4 times 1 times 5 is 20, and 4 minus 20 is negative 16. Square root of a negative, I'm going to pull out an I, and the square gives me I times square root of 16. But the square root of 16 is 4, so I get plus or minus 4i over 2. So the square root of negative 16 is plus or minus 4i. So remember, when we solve using imaginary numbers, we want it in standard form. So therefore, this is my a, 2 divided by 2, which is 1, plus or minus my bi, 4i divided by 2, or 4 divided by 2 is 2i. So I get my two imaginary solutions from this quadratic equation here are 1 plus and minus 2i. So I have this solution here still, x equals 3. And from this equation here, I just got my two solutions of 1 plus and minus 2i. So here are my three solutions. I have one real solution of x equals 3, and two imaginary solutions, 1 plus 2i, and my second imaginary is 1 minus 2i. Don't forget, you can always use quadratic formula to solve this, whether it's factorable or not. The quadratic formula will always work. If you do notice that something is factorable, like the last problem, it just might make it quicker and a little easier to work. But I could have solved the last problem with quadratic formula the same way I solved this one. I would have gotten real numbers, though, instead of imaginary.